The way kids interact with each other and the way the kids reflect on their own understandings is so different. It's a shame my own kids don't get to experience it at home, my own children, because everything that happens in my classroom is the classroom I always would dream for them to be a part of. Attentive listening to each other, careful consideration of their ideas, thinking back to experiments they had done on previous days or weeks or even years ago, reusing ideas between grades, between units, writing, expository writing that's far more evidence-based, argued out from scientific principles. The attention to each other's ideas and the classroom culture that's built feels like real science. And not real science in just that we're going to do a series of labs. Real science in that we're going to think hard about some really difficult questions and let questions drive our thinking. So the driving question board is a key part of our units. Sort of is this space where we keep track of our learning as the unit progresses, and it's a space where we motivate what it is we want to figure out. And there's a question that guides the content and the practices of the unit, but under that we hang all the kids' questions that can be linked in. So in a particular unit, like the one we're studying right now on biology, our driving question is, why do organisms look the way they do? And this is going to motivate two big areas to investigate: things that we inherit and things that are environmentally influenced. Kids bring in lots of cases of their own experiences to that question. Families they know, friends they know, things that they've thought about for the last 12, 14 years. And so that driving question board becomes a space where kids bring in their own data, and the class brings in data. And over time, we collect more and more data and drive more and more questions from our own experiences in the world, so that all those cases end up being things that we can answer by the end of the unit. We're not just learning to learn the science, we're learning to figure out what it is we really want to know. So for example, up here we have a series of cards the kids have posted. One kid says, our family has family friends, and in that family, the mom has brown eyes and the dad has blue eyes. Two of their kids have brown eyes and one kid has blue eyes. Why is this? And that kind of case is similar to a lot of other kids' cases, but each kid has their own unique story that they want to be able to answer. And by sharing those out and having them be a part of the unit, kids realize we have a shared mission in science. And that is, if we can figure out the answer to my question, my answer can help inform the answer to your question. We were lucky enough to be able to pilot other materials besides iQuest in the past, and I can say pretty confidently that other materials simply don't engage kids in scientific practices the way iQuest does. iQuest takes it seriously when they say develop a model. That's a scientific practice in the next generation science standards. That means kids are going to reconstruct or reinvent some really powerful ideas in science, whether that means they're going to invent natural selection or they're going to create a model for inheritance. What we're really asking kids to do is carry the heavy lifting of these scientific practices on their own shoulders. So when it comes to building models, evaluating them, writing scientific explanations based on evidence, or arguing from evidence, there's not another program like it. So being able to kind of talk both from a math and ELA perspective, it might be useful to think about where the Common Core overlap and leverage is in iQuest. I think the most powerful area is in writing, speaking, and listening. These are practices that make up maybe 50% of the curriculum. Kids are having to think through their ideas, attend to each other's ideas, and link into them, and then reuse those in their writing. Math also ends up being a big component. In fact, in this unit that we're working on right now, our biology unit, kids are going to be working with scatter plots. They're going to be working with linear regression models. They're going to be working with comparing histograms. And all those fall well within what the Common Core asks kids to reason about for math, both at 7th and 8th grade. And typically, the unit can be thought of as a project of sorts. We have sort of a case that we want to figure out, or we bring cases in that serve sort of as the context we want to be able to account for and explain. On the same token, sometimes we take those contexts and then do some engineering tasks with it, or do a technological design that comes off of it. But really thinking through sort of the project as the cases that kids bring in and the cases and phenomena that we encounter in the unit would really pitch this program as being a project-driven curriculum where phenomena and real-world examples are what we're trying to figure out.